Chapter 15.8 Spherical Coordinates. We have learned what is cylindrical coordinates, and today we will study a new coordinate called spherical coordinates. Given a point x, y, z, Given a point x, y, z in the 3D plane, 3D space, we can connect the point to the origin, and we'll call the distance rho, and we'll project the point to the xy plane, and as usual we'll get this polar coordinates r and theta. And there is an angle between the radius of length rho with the z-axis, and we call this angle phi. And we'll use these three things, rho, phi, and theta, be the spherical coordinate. So let's see the relation between x, y, z, and rho, theta, and phi. First, we can see if we know rho, theta, phi, we can write down z as rho times cosine phi, right? Because you can project onto the z-axis. So you get this right triangle, and the corresponding we'll have r equals rho times sine phi, right? That's the projection onto xy plane. And then because of the polar coordinate, we can say x equals rho times sine phi times cosine theta, and y equals rho times sine phi times sine theta. Okay, and so if we know the spherical coordinate, we can recover the x, y, z. On the other hand, if you know x, y, z, then you can write down rho as just the sum of the square root of the sum of the x, y, z squared. And by plotting x, y, z, you can recover the phi, and project onto xy plane, you can recover the theta. So let's see an example. If I know, before that, let's see. There is a range for theta. We know it's between 0 and 2 pi. And there is also a range for phi. And the phi is always between 0 and pi. And 0 means north pole. And pi means go all the way around, so it's south pole. Right? So let's see. If you have a point with rho with x, y, z equals, let's say, 0, 2 root 3, and negative 2. Then let's find out rho, theta, phi. Rho is just the square root of x squared plus y squared plus z squared. And you can see it's 0 plus 4 times 3, 12 plus 4, and that's 4. Alright, to find out phi, let's sketch this point. X equals 0, y equals 2 root 3, and z equals negative 2. So it's somewhere here, right? So you can see if you connect them, and this is phi. So what is phi? Well, cosine phi equals z over rho. So that's negative 2 over 4, which is negative 1/2. And since phi is between 0 and pi, so phi should be 120, or you can say 2 pi over 3. Alright, then what is theta? Well, if you project this point onto xy plane, you will see it's right on the y-axis, because x equals 0. So that's theta, and you can see theta equals pi over 2, because it's on the positive y-axis. Right? So let's see if we know rho, theta, phi equals 2 pi over 4 pi over 3. Can we recover x, y, z? Z is easiest. It's cosine phi times rho. It's 2 times cosine phi, which is phi, this one. So what is cosine pi over 3? It's 1/2. So it's 1. And how about x? Well, x equals rho times sine phi times cosine theta. And rho equals 2. Cosine sine phi equals root 3 over 2. And the cosine for quarter pi equals root 2 over 2. So that's cancel the 2 here. So you get root 6 over 2. And for y it's rho times sine phi sine theta. In this case, sine theta equals cosine theta because pi over 4, so it's also root 6 over 2. Alright, so that's the conversion. Now let's see some surface. If I give you a surface like that, z equals, rho equals 2z. And what does that mean? Well, that means this equals rho times cosine phi. Right? What is cosine phi? Cosine phi equals 1/2. Right? Because that way you can cancel the rho. Okay. So that means phi equals pi over 3. And that means you have a fixed phi with arbitrary rho, and that's a cone. Right? The cone at angle pi over 3. Oh, this I didn't draw it very well. It should be more like that. Right? So that's a cone. And let's see, how do we do the integration? Suppose you want to do integration in this way. So let's first find out how do we write down dv in spherical coordinates. Suppose you have, this is origin, okay? You have a volume element. So this will be a small rectangular prism, and this is just a d rho, because rho and becomes rho plus d rho. And this one, it's on a circle with radius rho, and the angle here is phi, so this will be rho d phi. Right? And this one, this horizontal part, is actually on a horizontal circle centered at here. And you can see the center of the circle is on axis. So the radius is not rho, it's actually r, which means equals rho sine phi. And this angle here is d theta. So the length of this is rho sine phi d theta. Right? The radius of that horizontal circle times the angle. And so what is dv? dv is the product of all three of them. So it's rho times, d rho times rho d phi times rho sine phi d theta. Or if we reorganize them, it can be written as rho, see the two rows, so rho square times sine phi, then d rho d phi d theta. So it's more complicated than before. In the cylindrical coordinates, we only have a rho in front of a d rho d theta dz, but now we have this rho square sine phi. And don't forget this sine phi, because that's something unusual. Alright, now let's see the integral. And And of course, you need to write down the range in terms of rho theta phi. But let's worry about that later. Now you need to write down f as a function of xyz, right? What is xyz? Let's recall that x equals rho times sine phi cosine z, rho times sine phi sine z, sine theta, sorry. And then you have a rho times cosine phi. All right, then you have rho square sine phi d rho d phi d theta. Okay, it looks very complicated, but we will use it only if it makes it easier. So you will see, although it looks long, but we usually don't have a very complicated integral. All right, now let's apply to a few examples. The first example is an integration over a sphere. The sphere says x squared plus y squared plus z squared is less than or equal to 1. So it's a sphere of a radius 1. And then we have this e to the square root of x squared plus y squared plus z squared, plus z squared dv. Alright, so apparently, this is a sphere, so we should use the spherical coordinate. Alright, and actually it's really easy. The integrand is particularly easy. It's just e to the rho, right? And how do we write on dv? Rho square sine phi d rho d phi d theta. Okay, what's the range? It's a sphere, so theta goes from 0 to 2 pi, and phi goes from 0 to pi, from north pole to south pole. And rho goes from 0 to 1 because that's the radius. Alright, then that's it. Then integrate. And you can see the integration for rho theta phi can be totally separated. For theta, for phi, then for rho, don't forget the sine phi and the rho square. Okay, then it can be done. This is just 2 pi. And this one will give you negative cosine phi from 0 to pi. And this one you have to do integration by part. And I leave this to yourself, and I will just tell you the result. It will be this. Okay. Alright, then plugging the limits. So you have 2 pi times, this is 1 minus negative 1, so it's 2. And then you have, plugging 1, you get e times e times 1, so you get e minus 0 give you 1 times 2. So that's your answer. Okay. Of course, you can write on this as 4 pi times e minus 2. Alright, done with the problem 1. Let's see another example. This one would be a little bit more complicated. It asks you to find the volume of a 3D domain, and the 3D domain is like this. It's E is defined by R is, sorry, not R. Z is greater than or equal to that, and Z is less than or equal to that. Okay, so let's see if we can convert this into a spherical coordinate. Alright, this one equals R, right? So you can see we have rho times cosine phi is greater than or equal to rho times sine phi. Well, then you can cancel the rho. So it means you can divide by that, you get a tangent phi is less than or equal to 1. And what does that mean? It means phi is less than or equal to pi over 4. Right? And of course phi is greater than or equal to 0. So that's the range for phi. And let's see what the second one. Second one says rho times cosine phi is less than or equal to rho squared, right? So let's cancel the rho. So you get rho is between, rho is greater than, no, shouldn't be greater. Let's see. It should be, sorry, the other way around. My bad. So this should be greater than or equal to. So this, otherwise it's infinite. So this is greater than or equal to. So rho is less than cosine phi. Alright, let's try to sketch it. Phi is between 0 and 4 pi, so that's above the cone. And rho is from 0 to cosine phi. So when phi equals 0, it's 1, and when it's phi equals pi over 4, it's somewhere shorter. So that's kind of like a circle, but actually it is a circle, but the circle is not centered at origin, it's centered at like that. Right, that's circle. It's centered at 1/2. So it's this 3D thing. Okay, it's like a cone with a big top. So let's see, what is the volume? Oh, volume, just integral that. And don't forget the rho squared sine phi. And for theta, it's either 0 to 2 pi. And for phi, it's not 0 to pi anymore. It's only from 0 to pi over 4. And for rho, it's from 0 to, not a constant, here, 0 to cosine phi. Alright, let's just do the integral. Okay, for pi, for theta, it's just 2 pi. And then for theta, it's 2 pi. For phi, it's this. Let's see, what's sine phi? And we have d phi. And for rho, what do you have? You have rho squared. They have rho cube over 3, right? Then plug in the limits. You get a cosine phi cube over 3. Alright, then let's simplify that. 2 pi over 3. Okay, how do you integrate that? You push this one into d of negative cosine phi. Right? Then integrate that. So you will have cosine phi to the 4th over 4. You can call this u substitution, right? They have a negative sign over here. And you plug in 0 to pi over 4. Alright, then let's see the answer. So we have 2 pi over 3. And then since there's a negative sign, we can flip it. So plug in 0 first. 1/4 minus plug in pi over 4. Cosine pi over 4 is 1 over root 2. Square is 1/2. Square again is 1/4. So it's 1 over 16. And then this is 4/16 minus 1/16, so it's 3/16. And 3 cancels 3. So 2 pi over 16, which is pi over 8. Okay, that's another example. We'll have 2 more examples, then we're done. Okay. The third example is to find out the centroid of a domain. Central means the center of mass, assuming the density is constant. So this time, this E is defined by that. Square root of 3 times Z is greater than or equal to square root of x squared plus y squared. And x squared plus y squared plus z squared is less than or equal to 1. Okay, actually it's very similar to the last problem. The first one, we rewrite it as root 3 times rho cosine phi greater than or equal to, that is nothing but r, the polar coordinate r. So it's a rho times sine phi. So we cancel the rho and move it over there. So you get a root 3 is greater than or equal to tangent phi. And what tangent give you root 3? You know, it's this one, right? 60 degrees. So it means phi is less than or equal to pi over 3. And then that's between 0 and pi over 3. And the second one is even easier. It just means rho is less than or equal to 1. So this time we have a more regular cone. So this is pi over 3, and this is a sphere, center and origin, so that's your cone. Okay, so it's a very wide cone. Okay, where's the center mass of this guy? Well, it should be somewhere, this is z on top, this is 1, right? So it should be somewhere here, right? Along z-axis. And so let's say, what is the z bar? It's the integration of z dv over that domain over that volume, right? So let's find out the denominator first. The volume, okay, what is that? If you remember, this is phi, this is phi, this is rho, right? So it's between 0 and pi over 3, and 0 and 1, and of course for theta it's 0, that's simple. Sine phi d rho d phi d theta. And that integral is pretty easy. For theta it's 2 pi. For phi it's a sine part, right? So it's a negative cosine phi from 0 to pi over 3. Then for rho it's just a rho cube over 3 from 0 to 1. Alright, so you have 2 pi times, plugging that, you get negative 1/2. Then this is 1, so you get a 1 minus 1/2, which is 1/2. And this gives you 1/3, so it's pi over 3. Okay, easy. And how about the integral of with z? Then you have this limit is still same. And this is pi over 3. And then you have 0 to 1, right? So what is, okay, z, right? What is z? Z is rho cosine phi. Okay. Then don't forget you still have that term. Alright, let's see. How do we get to that? Still separate them. For rho, also for theta it's just 2 pi. And for the phi part, it's a cosine phi sine phi, right? You can merge cosine phi with d phi, so you get a d of sine phi, then give you sine phi square over 2, and 0 to pi over 3. And for rho, it's just rho times rho square, which is rho cube, and you get a rho force over 4, 0 to 1. Alright, what is that? 2 pi times, I'm plugging that, sine pi over 3 is root 3 over 2, square will be 3 over 4, so it's 3 over 8, and this is just 1/4. So let's do some cancellation, 3 pi over 16. Alright, finally, what is z bar? That's 3 pi over 16 divided by our volume, which is pi over 3. So that is, you flip the 3 up, you get 9 over 16. And that seems pretty good, because it's a little bit more than a half, right? Look at our domain. It's this guy. The top is 1 and bottom is 0, so the middle is 1/2. But the top half is a sphere and the bottom half is a cone, so it should be above the middle point. So it's a reasonable result. Okay. Finally, let's do the last example. The last example would be an integral that has a given form. Let's just go to the next page. The integral is given. Alright, so it's given in x, y, z, and as you can see, the limits are quite awkward because they have square roots, and more naturally they would be written in the spherical coordinates. Let's see how. So let's see, what's the range of x? X is, let's first plot what's happening in xy plane. X is between 0 and 1, and y is between 0 and that. What is that? Y equals square root of that. That's certainly a circle of radius 1, right? So it's this. So that's the xy plane. Then on top of that, you will have a 3D object between the lower limit and higher limit. The lower limit is, z. Z is greater than or equal to that, which is r, and we have seen this twice, so we know this means phi is less than or equal to pi over 4, right? Because when phi equals pi over 4, z equals r. So it's a cone. And what is the other one? Okay, the other one is z is less than or equal to that. So that's certainly a sphere, right? But that means less than or equal to 2. So what is the radius of the sphere? It's not 2, it's square root of 2, right? So it means that. So still we have a cone with the top of the cone is a sphere, but it's only on the first quadrant, not on the entire sphere. All right, so we need to rewrite this integral, but don't forget the xy. So let's write on the limit first. What is the limit for theta? It's 0 to pi over 2, not 2 pi. And for phi, it's 0 to pi over 4. And for rho, it's 0 to square root of 2. Okay, let's write down the xy. X, y, theta, then rho square sine phi d rho d phi d theta. Okay, so it's kind of long, but still it's separable, right? You can see the rho and phi. A lot of sine. So let's do the theta first. So it's cosine theta, sine theta, that's it. And for phi, it's sine cube. And for rho, it's rho to the 4th. All right, that's the easiest. You can combine the cosine theta with d theta. So you have sine theta squared over 2 then, okay, how to do the middle one? You can combine it with d of cosine theta with a negative sign, right? But then how about this sine square, which is left there? Well, you need to write out this as a function of cosine phi, right? 1 minus cosine square equals sine square. So okay, the last one is easy. Go to the 5th over 5. Alright, let's see what do we get. Plug in pi over 2, and the sine of that is 1, so this is 1/2. And then what's next? Alright, so we have a negative sign. So this will give you cosine phi minus cosine phi cube over 3 right? It's from 0 to pi over 4, but because negative sign, let's flip it. Okay, and that -1 is taken care of. And then last one is either just root 2 to the 5th, which is 4 root 2 to the 5th, over 5. Okay, now let's cancel some. This 2 and 4 equals 2 root 2 over 5. Then what is this? Plug in 1, you get 1 minus 1/3. Plug in pi over 4. This is let's see. This is 1 over root 2, right? That's cosine pi over 4. And its cube would be 1 over 2 root 2. And divided by 3, 1 over 6 root 2. Right? And this minus sign becomes plus sign when you flip it. Okay, we're almost done. So let's simplify this a little bit. 2 over 3 minus, this is 1 over root 2, and this is 1/6 of that. So cancel them, have 5/6 of that. Right, so let's do some cancellation. Times that, you get a 4 root 2 over 15 minus, cancel the 5, cancel the root 2, cancel the 1, 2 and 6, and get a 1/3. Or if you like, you can write down this as 4 root 2 minus 5 over 15. Okay, that's it for this last example. And you can do your homework, and we will do the review next class, and we'll have an exam after that. Okay, thank you. Bye.